Yeah. Are you able to see my screen?
Yes, sir.
Okay.
Yes, sir.
Okay. Okay. See, last week we saw what functions are, and probably by now uh, most of you are able to write a function given a problem statement. So, with one more example, and then we shall move to see the further details of functions. So, suppose if I have to find GCD of two numbers. Okay, so you might have done this somewhere sometime back in your first year or somewhere. Given two integers, let us say 24 and 16, you have to find the number which is one among the largest divisors of both the numbers. For instance, we know divisors of 24 are 2, 3, 4, 6, 8, then 12. Okay, so these are the divisors of 24, and the divisor of 16 is 2, 4, 8, right? Only three divisors are there. But if you compare the divisors of both of these numbers, the largest among the two is 8. So we need to find out this number without listing all these divisors and then picking up the largest common one. So there is one algorithm called as Euclid's algorithm, which makes it very simple. We shall see through its implementation how Euclid's algorithm can quickly find out the greatest common divisors of two numbers. So Euclid was a mathematician who existed some 2,300 years back in the city of Athens, and he at that time has devised this algorithm, and it is so very relevant even today. So let's see how it Euclid's algorithm works. So you need to have two numbers. Let us say a equal to 24 and your b equal to 16. And we need to write a function called as GCD a comma b. Now, when I list all the divisors of a and b and find the largest among them, it will return an integer. So let's take a variable c and get that into c. So you just have to write GCD of percentage d and percentage d is equal to percentage d. So format specifiers will fill the values of a, b, and c at appropriate points. Now, when you want to write a function, always think of what value it is returning. So first part, you must know what to write here. So we know that GCD has to give me an integer value, so the return type is int. Then give an appropriate name, GCD, and what are the arguments it is taking. So here the formal arguments have to be written along with their data types int a and int b. You can take int x comma int y also, that is fine. Now how GCD works is using Euclid method is that it finds the remainder of the two when I divide a by b. So we need a local variable remainder. The first step in proceeding is first find the remainder of dividing a by b, and keep on dividing this until remainder becomes 0. So while remainder not equal to 0, you do the following. So once you find the remainder, the b value has to be copied into a, the remainder has to be copied into b, and again the remainder has to be found before I proceed on to next step in the loop. So again you find a percentage b, right? So all this might be little difficult to understand, but let's trace this program and see what is happening. So initially we got a equal to 24 and b equal to 16, right? So can you tell me what is the remainder after dividing 24 by 16? 8, right? So we got remainder as 8. So is remainder 8 equal to 0? No. So it will enter the loop. Okay. Now I have to copy whatever is there in B into A. So A we had 24, that will be replaced by B. So we'll get 16 as A value at this step. Okay, and then the b value will be the remainder that we got in the previous step, that is when we divided a by b, which is 8 now. Okay, then again you should proceed to find the remainder of this number combination 16 and 18. So what would be the remainder now?
0.
0, right? Okay, so once you go back here, remainder is 0, right? So once the remainder is 0, it will come out of the loop. It is just a coincidence that on the first instance only remainder has become 0. In certain other number combination, it will take a little while. That loop will run several times before remainder becomes 0. So once you come out, where do you think is the answer for GCD of two numbers? Okay, so if you observe these three numbers, 0 is not the answer, 16 is also not the answer. The answer is 8, okay, which is in B. So when you come out of the loop, you return B, okay. So that will be always so, irrespective of what numbers you take, okay. So once you write this function, what remains is only the function return prototype has to be written into GCD, then int comma int, okay. So if I run the program now, yeah, so as you can see, GCD of 24 and 16 is 8. So you can put any other numbers and see whether it is working well. So 21 and if you put 12, okay, so as you can see, 3 is a divisor, okay. Uh, any other divisor you think of? Because one is odd, other one is even. So possibly 3 is the only greatest common divisor as it is so. But if you write this as 15, then you will see 3 is a possibly 7 is the greatest common divisor, as you can see. Okay, so you can write functions. It is always better to write function because you have neat and clean code which is doing one task, that is finding the GCD of two numbers. Whenever you write functions, please write here some comment like finding GCD of two positive integers, okay. uh, Greater the positive integers means they should be greater than 0 using Euclid's method, because there are other methods also to find GCD. You must specifically say what it is doing. So always it is better to comment how what this function is doing. So we'll move on a little bit to know further details of how functions are made use in C program. Now, printf is a library function. All of you agree? So, printf is a function.
Okay.
Now, this printf function, if you see the prototype which is there in stdio.h, it is returning an integer value and taking a pointer to uh, a string like this. Okay. So, this argument which I am passing here, hello world, we understand it is going to str, but its return type is int. I am not using that int anywhere. So can I see what is the value it is returning? Now you can take a variable c and
11.
do this and print c. Yeah, you guessed it right. So we'll see what is the value of c here. D here. Now it will print the number of characters it successfully printed on the screen.
Yes.
Okay. So 11 characters are there in hello world. So printf will return how many characters it could successfully print. Now why I'm saying successfully, because sometimes the buffer may be full. If you give a very large string, some part of that may be printed, say remaining will be still in the buffer. So it will only print how many characters were printed on the console. All right. So this is you must know a little bit about printf. You could have printed number of characters in another printf only like this, right? Percentage d, and within that you could have written printf. So this also could have given the same answer instead of holding the value into another variable and like that. All right. So know that the library functions are also defined like the way we write functions. Some functions have return types and also they take certain set of arguments. Now main is also function. All of you agree?
Mm.
Okay. Now what are the arguments function takes? I am not indicated anything here, and the arguments of main are optional. But if there are any, there are three arguments here. One is int c, other one is char star argv, and another one is char star envp. Now what are these things? We shall see. The first one is these are called as command line arguments. Why they are called so, we shall see shortly. It means when you execute this program, normally uh, if you implement it as a command on the DOS prompt, this program will be a command, and you want to pass some values at the command prompt, then you can make use of these three arguments. Now let us for a moment leave this aside. We'll only discuss about argc and argv. Now argc will value number of command line arguments. Okay, how many command line arguments that you have passed. Okay, and the second one is the pointer to an array of command line arguments. It means it will point to a set of strings which you can print in your program. So let us see how I can do this. We know that int c stores the number of arguments, so I can set up a for loop here for I equal to 0. Since the command line arguments all come in an array, so array, as you know, it starts at index 0 and I less than c, I plus plus, and here you can print them. What all is coming through? Printf percentage yes, comma argv of I. So argv is an array of pointers to strings. So if I put an index I, it will print that string. So each string is terminated by null when you pass them. Now where I am going to pass the command line arguments, as you can see in this box here, it is written command line argument. So here I can pass, let us say, Ajay uh, Devgan or something like that. Okay. Now Ajay is one command line, Devgan is another command line, but it will take the name of the file also as one command line. So as you can see, the file name is written as main.c. The argv of 0 will be main, argv of 1 will be Ajay, and argv of 2 will be Devgan, like that. So if I run this program, argv of,
Array pointer.
yeah, now it is correct. Hmm? So it is char star argv, it's array of pointers. So I have not
Mm.
indicated that. I was just printing one pointer. That is
Yeah,
not true. It is array of pointers.
yeah.
So as you can see, dot a dot out. So when you compile main dot c, it will generate an executable file with name a dot out. So it is printing that a dot out. Then it is printing that first command line, and then Ajay. If we leave one space, things become a bit clearer. Okay, fine. So where can I use it? Let us say I have written a function to concatenate two strings. So you can read the two strings which are passed as command line and process them. So that is one use case of command line arguments. Hmm? Okay, so main takes two command line arguments and you can make use of them. And there is a third command line argument, that is char star envp, like this. Now this environment variable, so as you know, there are certain environment variables. You might have set some environment variables like this. If I go to Windows Java home, or just home, okay. So these are all environment variables. So these environment variables sometimes will be required and you want to print them. So the way to print all command line arguments is you don't require argc anymore. You just got to set up a while loop while and sometimes these may be required to know which language are you using and what is your home directory and all that. Hmm? So remember that main has three arguments and all these three are optional. So even if you leave them out, you can just go ahead with the program. Only when you require command line arguments or environment variables, use them. Otherwise, it is optional. Yeah. Now, we have looked at what functions are, and along with functions, you need to know can function call itself. Okay. So we have seen one function calling other, the main calling another function. Can function call itself? That is, can main call itself, or GCD can call itself, right? So if at all you are able to do that, then such functions are called as recursive functions. If there is a call to the function within the body of the function, then it is a recursive function. So let us say this is useful whenever the problem that you are solving, okay, is of recursive nature. Remember, you cannot use recursion anywhere, everywhere. It is only possible when the problem is recursive. For example, you know that n factorial can be written as n into n minus 1 factorial. So the factorial is appearing on both left hand side as well as on right hand side. So in general, we can write fact of n.
Yes.
This, if I translate this into a function, fact of n is n into factorial of n minus 1, right? If I knew factorial of n minus 1, I can calculate factor of n simply by multiplying it by n. Okay. And normally when you do recursive functions, will always have a boundary condition. It means the recursive function should terminate. So some condition is required to terminate the recursive calls. Otherwise, the recursion goes indefinitely until the stack becomes full. So what is the terminating condition for this factorial? We know that factorial of 1 is 1. It means once as I go on reducing n value by 1, it means if I have to find factorial of n minus 2, n minus 1, I can do it by n minus 1 multiplied by fact of n minus 2, isn't it? So I can go on like this until I reach some point where this will be 2 and you will be left with fact of 1, isn't it? So the value in the function will always be 1 less than the value here, right? So once you get fact of 1, which is known value, you can find fact of 2, right? So this is what is fact of 2. So fact of 2 is nothing but 2 into fact of 1, which is 1. So you get answer of fact of 2. Now if you know fact of 2, then you can find fact of 3, which is 3 into fact of 2, isn't it? So fact of 2 you have calculated as 2. So the result will be 3 into 2, which is 6. And you can just do this recursively backward to get the final answer. So how do I write a recursive function? So we know that factorial gives me integer value. The return type of factorial, the recursive function, let me call it as fact. And you are passing an integer value here. So you must mention the data type int n. Now in recursive functions, there will always be a if condition, right? So if n equal to 1, we know what to return. We know that factorial of 1 is 1. So I return 1. Else, we don't know what is the factorial of higher values of n. So that I need to calculate. So that I do it by using, sorry, if the value of n is received, then we know that the result is n into factorial of n minus 1. So as you can see, I'm calling the function within the body of itself. This is a function. Okay, and this must also be returned. Return n into fact of this. All right. So this function here, this is a function called to itself, isn't it? And you will be calling this fact function from your main. All right. So suppose you add main here, you take some int n equal to 5, and you will call fact of n, and possibly hold this result in result like this and print. Okay. So this in main you are calling the function. This is understandable. But within the body of the function you are calling fact. So this is recursion. Right. So what actually happens when you call a recursive function? We shall see. It makes use of stack. So before that process of finding how exactly factorial is found recursively, we'll implement and see whether this works for us. All right. So let me go to this GDB here. So we'll take int n equal to 5 and int result equal to fact of n, and print this result. Printf factorial of percentage d is percentage d, and then you can pass the value of n and the result that you get. Okay, so the way to write factorial here is int fact int n. Hmm. So the first step in any recursion will be a terminating condition. If n is equal to 1, you return 1 here, else return n into factorial of n minus 1. So the programs will be very short if you write things recursively, but they take longer time because a lot of stack operations happen here. Hmm. Now to test this, we need to write the prototype
Yes.
just like this. And now if I run the program, hopefully we should get the answer. So factorial of 5 is 120. Hmm. So all of you just try this out, and we shall see how is it able to find out or arrive at 120 answer. Hmm. Okay, so just give a try. Just take a quick look at the program and
Yeah,
see.
I'm attempting.
Yeah,
I'm attempting.
yeah,
Yeah. You continue, sir.
okay,
I'll done, sir.
yeah, good. So let's see how actually it is calculating this factorial of given number. Let's say n equal to 4. So when you invoke fact with number 4, what happens is this is where you are. You are at this point. You are calling factorial by number 4. So we know that when you enter any function, the value of n is pushed onto stack. Hmm. And that is what exactly happens. So you will see 4 pushed onto stack, and within this n is not equal to 0, going to the second part here. So again the return address of 3 is saved here. So this is what comes here. So 4 into factorial of 3 comes when you enter the function, right? Now we don't know factorial of 3. Again we decrement n by 3. So when we enter the function with value 3, n was 4 here, it became 3 here because n minus 1. So next time when you iterate, this is 3 and you'll get 3 here. Next time it becomes 2 here. So in the next step, as you can see, it is 3 into factorial of 2. We don't know still factorial of 2. We again go back with another reduced value. So next time the n value will be 2 and argument value will be 1. This time also we don't know. Again we decrement n by 1. Before that we keep a 1 here and pass 0. So when it is 0, we know it is 1. So what happens is the base case is reached. the base case is reached here. So this is called as stack buildup. So stack will build like this, right? And once you reach the boundary case or the base case, it will start, the stack will start unwinding. You call it as unwinding of stack. So once you know the value of factorial of 0, it is substituted here. We get answer as 1. Again, we go back to the previous step where factorial of 1 is 1. Then we get value of factorial of 2 as 2 here. We use this value to go to this step. We know this whole thing is now equal to 2. We have got the answer, and now calculate the result as 6. Again, we know factorial of 3 is 6, so it will come and substitute here. 6 into 4, 24. So this is how the stack will build up until you reach value of 0, and it will unwind in the backward direction, and at the end when you finally return, that time the value 24 will be returned back to the calling function, namely the main function. Is this point clear? Hello?
Yes, sir.
Yes.
Okay. Yeah. So recursive functions are not the normal way of functions where in normal way you have a loop and you understand the loop because loop itself is telling you what is happening. But here it is all happening in the stack. You have to draw this stack diagram to understand how the stack buildup is happening and it is unwinding to get the result. Now, another example for recursive function is if I want to find sum of first n integers. So it is just like factorial, just that you write a function called as sum n. And we know that to find the sum of first n integers, what is the formula? Sum of n is equal to, I should have written it, n plus sum of n minus 1. What is the boundary case? Sum of 0 equal to 0, isn't it? In fact, 0 doesn't add any value. You can take the base case as sum of 1 is equal to 1. Hmm? So here how do I write? If n is equal to 1, return 1. Else, return. Can you tell me what I should write here?
Sum of n minus 1
Yeah, just sum of n minus 1 like this.
and return sum of n minus yes and semicolon. Yes.
Yeah,
Yes.
only this.
No, n plus sum of n minus
Ah,
1.
N plus
sorry.
sum of this. Yeah,
Uh-huh.
good.
Okay.
Hmm?
Just now I missed it.
Yeah, yeah.
That.
So good. So initially, this difficulty will be there, but once you know what to write, because you just have to remember this statement here.
Yeah.
Hmm? This first part n should be there, and then
It should
n
be there.
minus 1 should come. Hmm? So there are many instances where recursion is required. In fact, uh, like if you want to do sorting using quick sort or merge sort, you require recursive implementations, right? So one such example we shall discover later. Hmm? All right. Now, what more needs to be done in functions is pointers to functions. Okay, so pay attention here. This is slightly more difficult to understand. Pointers to functions. So we know that pointers are used to point to other variables, right? Like we had int a and we had a pointer int star p. P can point to a by using its address, right? This is what is pointer. So can I use a pointer to point to a function? As I told you, every function or all programs are stored in memory. Even functions have memory addresses. All of you agree? Functions
Yes.
have
Maybe.
memory addresses. Hmm? So here again, just like your array, function names themselves are addresses. Hmm? So using this, I can make a pointer point to function. So let's see how I can do that. Let's say we have a function called void show, just simple printf here. I am in show. Hmm? Now from main, you know how to call this, right? You simply use show here. Hmm?
Sure.
So show function will be called and I am in show will be displayed. But can I do using a pointer? Right? So the way to do that is you have to define a pointer to function. The way to define pointer to the function is first you have to mention what is the return value of that function. So put a round bracket, say it is returning a void, and then the name of the function has to be replaced with a star pointer. Let's say fptr. You can use any variable name. F stands for function and ptr is pointer. This is the pointer to function. Okay, and here you are not passing anything, so it will be again void. So this is a pointer variable which is capable of pointing to any function which is not returning anything and not taking anything as argument. So I can now say fptr equal to just show, because show itself is the address. I can assign to fptr. Now if I want to call your show function, I can do that using fptr. Using fptr, now if I just say fptr here, this function will be called. Now you might all be wondering if I can do that using show, why I need a pointer to do that. So there are some useful scenarios where function pointers are more suitable than
Can you
calling the
repeat that?
functions. Hmm?
Can you repeat that? What is the part of second word over here? Word first word is the part
First is the return type.
of
Hmm?
function.
Second is the star symbol, then any variable name here.
Okay.
And third is what is the argument here.
Oh, okay.
Suppose if we had in the show function, if we had int here,
Uh,
int x, something like this, you would have written int here.
okay.
Hmm? So this
Okay.
is the argument list, and this is the return type.
Return type of the function.
Yeah,
Okay.
I'll show you through a program how it works out.
And sir, where we are declaring this pointer, we can directly initialize, right, to show.
Yeah, yeah. You're declaring right here. The declaration of a pointer is here only. It's
Like
you.
if I do declaration, like whatever pointer is equal to show directly
Yeah, yeah,
instead of the
yeah. This
second.
is where the initialization is happening. Pointer name equal to name of the function.
And here we don't need to pass the the basis, right? The normal how we use for the function call. So like that we don't need to call that show
No, if you have
any.
here, I think so. If you have an argument, for example,
Mm,
here in this case x, no, I have to
uh,
pass some value. Let's say 5.
okay, okay,
Okay, so let's see that in the demonstration.
okay.
Uh, See, for example, this factorial only I can invoke through a pointer. So we know that return type of uh, this function is int. Okay,
Mm,
then
mm,
star fptr, and it is accepting one integer.
Correct.
right.
So this is the declaration of a pointer. Now fptr equal to fact. Okay. Now instead of calling this function using the function name, I can say fptr and then pass the value n.
Okay.
The effect
So
would
what
be,
happens to below parts are int fact we have declared that will remain constant?
pardon?
26th line, int fact. We are again
Yeah,
calling it.
this will be
What
same.
will be?
This is the implementation of the function fact.
Okay, okay, okay.
I am calling this function using a pointer, not
Pointer.
using the
That's it.
function name.
Okay,
So,
okay.
the return type should be just the data type, not with a bracket. Hmm?
So one more doubt. Line number 15 will not be needed, right, in that case?
Yeah, this is not required. This is not required.
Okay.
Now, when you want to use pointer to function, just declare a function pointer. This is a function pointer declaration. Function pointer declaration. Hmm. Return type in bracket name of the pointer with a star, and then in bracket the arguments types. If there is only one argument, it will be just one int like that. Hmm. So in my write-up, I showed you we had void show like this, right? So here, how would you write the function pointer? So here, say uh, I am in show. Hmm. So if I were to write a pointer to this, I would do like this: void in bracket star fp and then void, correct?
Sir,
And
if we do equal to show there
yeah,
on,
you have to do equal to show here.
we can't do with declaration like declaration
I
and
think so. It can be done. Let us try. It should be possible. The show I have to write. Now, if I want to call show, I just have to use the pointer fp without any. Or I think so. With round bracket is required there. Yeah. If I use it without this, should it work? No, it doesn't. So this bracket is required. Hmm? So one or two corrections here. You should not write the function pointer with these brackets, the first thing. And when you want to
Hmm.
call the function, you should have the brackets here that already have. Hmm? If this were not taking any argument also, then it should have been fptr with brackets like this. Hmm? So just give a try. You also write a function and then declare a function pointer and try to do this. Let us see. So we'll see a very interesting use case of where these pointers to functions are used.
Sir, in your example for calling that function fact, right? You're not giving that braces. Why?
Where,
You're just asking function pointer is equal to fact.
pardon,
21 line number.
21. Yeah, yeah. So when you initialize the pointer to the function, no need to give brackets here. It is just the name of the function.
But when we are calling that function directly,
Where,
uh, so for show, right, 19th line number, you're
yeah,
just calling.
yeah. Here I am not putting bracket also. Here also I am not putting bracket. Just the name of the
So
function I am giving.
um, in what scenario we're using that brackets then?
Where,
Show of that braces if you want to use.
no, we are not using it at all here. If you want to directly call the function, then you are using like this.
If directly it has to be
Yeah,
called.
yeah.
But with the pointers, we don't need it.
No, while initializing, it is not required. Here it is not required while initializing. But when once you initialize the show with the pointer, but when you use show function, when you want to call show using the pointer, then bracket is required. Hmm? See, FP is pointing to show,
Yes.
correct? So you
Yes.
cannot just use pointer FP like that. You have to specify that it is a function which is not taking any arguments. Just
Okay, we are calling that show function here.
yeah,
Okay.
show function using FP only.
Okay.
Hmm. This is
And in the case of line number 21, um,
it is called here, no, in the printf
it is
statement.
called in a
Yeah,
printf. Okay.
Hmm.
Okay. Okay.
Called to show. Hmm. And here it is called to fact.
Okay.
Hmm. Using the pointer.
Why only FP and for int FPTR and for this character thing? Does it make any difference, sir?
I didn't get you clearly.
Uh, I mean, for pointer to function declaration for that factorial part, we are using the pointer as FPTR, correct?
Yeah.
And for show, we have used it as FD.
No,
Is it because there are two function to pointers in one program? That is why you are
yeah.
using
Yeah.
something different? Okay,
Since you
okay,
want
okay.
two pointers, this can be any name.
Right.
It can be X
Okay, okay,
or
okay.
it can be FPTR1 like that. They cannot be same.
Okay, 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 okay.
Okay. So, okay. So all of you are getting it?
Yeah.
No, sir, I am getting error.
At what?
I think I have replied you in that.
Man, still it is showing error.
Where is the error?
What error it is?
One very small thing to cover. Now, these function pointers can be passed as argument to functions. So that is one small thing that is missing. Let us say we want to do some such thing. I want to square a number. You know how to do this, right? Square it. Is my screen visible?
Yes, yes.
Yeah. I want to square this number. Return n star n. Hmm? And if you want to cube a number, you know how to do that. Int cube it. Sorry. Return n star n. Hmm? Now I can declare pointers to these functions, right? So how do I do that? Int then star fp or anything you can take. It is accepting one argument, and this should be initialized to square it. Hmm?
Okay.
Similarly, the second one, star fp1, returning accepting an integer, and then your qubit. Hmm? Yeah. Now I can have a function. Let us say compute. Hmm? This compute function will take function pointer itself as an argument. So here I can say int star fp then int. Hmm? And whatever number it wants to square, it has to be the second argument. So this is a function. Now depending on what you pass here, if you pass square, it will do the squaring. Otherwise it will do, you say return fp n. So things become clear when I call this here. Uh, let's say int n equal to 5. Now we just say compute. Here I am passing square it and n value. Hmm? And if you want to capture this in a result, int result and printf percentage d comma result. Now I need to specify the prototypes of these functions. The first one was int square
Compute.
int. Second one was int qubit int, and there was a function compute
Compute.
int hmm,
Compute.
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 It was accepting a function pointer which was returning
Star of
The int.
yeah int.
Int.
And then second
into comma
argument was
int.
a int.
Mm.
I think so. Just this is required.
Okay.
Now I am passing square it to this, so I should get square of the number 25. Okay. Now if I pass qubit here, I should get cube of the number, right? Okay.
Instead of square the qubit in the first parameter, can we pass fp or fp1?
Can you pass?
Can we pass fp? You have declared star fp above, right?
Huh.
Star fp is equal to square it and
Oh,
star
okay, okay,
fp1.
okay. You can pass FP. You should have passed FP actually.
Yeah,
Yeah.
fp of n.
No,
Okay,
you are
fp.
past. See, this first argument
Pointer,
is
yeah,
expecting
yeah,
only
yeah.
the pointer.
Right.
Okay.
Okay.
And if you want FP1, no, you will get cube of it.
Hmm. Okay. Understood.
Right? So what we have covered today is functions to pointer, which is a very important concept, especially when you are working with operating system. A lot of such things will come. So you should know how exactly declare a pointer to a function and use it. Hmm? So this is one very good use case scenario which you can try. Hmm? Okay, so we'll conclude today because you got a meeting, and I'll pass on few assignment problems similar to what we have discussed today. See if we are able to do that. All right?
Okay. It is pointer to functions or function to pointer, sir?
Pardon?
Yeah, this concept what you told, it is pointer to function or function to pointer.
No, no,
I'm
no.
kind of
Pointer to function.
okay. Pointer to function.
Pointer to function.
Okay.
Hmm?
Hmm.
Because see, right hand side is square it. No, this is a function.
Right. Function.
FP is
Right.
pointing to the